Hey guys, I am Julio Campos. I am your Algebra 1 CTL, and this is your Algebra 1 Unit 1 preview. Today I'll give you a quick overview of the unit, and then walk through the 3 stages of the unit plan, and end with a few reflections. As always, if there's any lingering questions, you can feel free to reach out to me, and if anything doesn't make sense or you want to add something you think might be useful for the rest of the cohort, feel free to send that along. Let's start with a quick overview. Unit 1 is very close to a pre-algebra unit. It's very skills based. It covers a lot of definitions, functions, domain, range. It also includes a lot of the underlying skills of algebra. Identifying functions, solving multi-step equations and inequalities, simplifying expressions. All of these topics are so fundamental to not only Algebra 1, but basically every high school math from here on out. So there's a lot of explicit instruction and skills-based problems throughout the unit, and especially in the unit assessment. This isn't really going to be the case in later units. We'll have a lot more investigations, we'll have a lot more actual performance tasks rather than straight-on multiple choice tests. But it's a really good way to ease our scholars into what should be a pretty rigorous year for them. Now, I have this quote up here. I'm a Cowboys fan, so you can be mad at me later, but this is from Bill Parcells. He says, when you don't know that you don't know, it's a lot different than when you do know that you don't know. And I think this is a place that we need to start pushing our scholars, and this is a great unit to do it. With having intentional do nows, intentional independent practice, even I&M and GP, you can really start to identify those misconceptions. You can really start to identify those gaps that scholars have. And if they can start building that process in themselves, identifying where they're lacking certain skills, it's going to make your year a whole lot better. So we'll go ahead and jump into stage 1 of the unit plan now. Alright, so this is what stage 1 looks like. It's always the part of the unit plan that takes the longest to actually plan or create, yet it seems like it gets the least amount of actual attention when the unit is executed, which totally makes sense. It's natural to focus on kind of the here and now of lesson plans and exit tickets, but I think there's a lot of room, especially in this unit, to have some pretty amazing discussions or Q&A sessions or whatever you want built around this part of the unit plan. And I'll get a little bit into detail about what I mean specifically. So I chose fairness and development as the global context, with the exploration being power and privilege. I think that our scholars are at the age that they're starting to come to terms with the world around them and are starting to identify some situations or circumstances that they deem to be unfair. This usually revolves around some sort of inequality or maybe the appearance of equality when really it isn't there. So that's what led to the statement of inquiry, which is that there cannot be fairness in a relationship that has a pattern of inequality. Obviously, this is a general statement, and I think with that kind of broad structure that it has, we can address a lot of things that are going on around our scholars, around us. You have the potential to talk about race relations in the country right now. You have the potential to talk about differences in socioeconomic statuses and how that affects their perceived trajectories as scholars. You can even talk on a more basic level about their peer-to-peer relationships. Do they have some sort of pattern of inequality in the power that somebody has over them, or vice versa? You can bring in bullying, a lot of different aspects to the statement of inquiry, and I think that's kind of the idea behind this, that you kind of put your own spin on it and you make sure that you address this with the scholars so they can kind of make these connections. And you'd be surprised. You might see some different connections pop up from these scholars that you didn't necessarily expect. Now that's a big kind of pie in the sky view of stage 1. From here on out, we're going to get a lot more content based. And that leads us to the inquiry questions. The factual questions tend to stay very math related, as do the conceptual. The debatable questions are my attempts at connecting to the statement of inquiry. These debatable questions are tough to introduce genuinely, but a great place to do that would be as a closure question. The factual questions are pretty straightforward, so I won't really address those, but there are some conceptual questions that I want to highlight, specifically number 1 and number 5. For number 1, Scholars don't often connect the vertical line test to the definition of a function, and that disconnect can lead to struggles retaining function information or the definition of a function. I think the idea here is when you're actually doing the vertical line test, explicitly show two coordinate points and show the fact that those coordinate points have the same x value going to two different y values, making sure that you're connecting what can sometimes feel like a discrete skill back to your original function definition. Also, number 5, connecting solutions and even domain and range to the real world is something that most of my scholars usually struggle with. Try incorporating this on most of your early word problems. You could even scaffold up to it by asking what types of solutions wouldn't make sense with the word problem, ignoring negatives or saying that fractional answers wouldn't make sense. A little bit of this could go a long way, building that kind of analytical side of your scholars. I'll go ahead and move on to the TEKS, the knowledge and the skills section of stage 1. If you haven't worked with TEKS before, there are readiness standards and supporting standards. There are more supporting standards than there are readiness standards, but on your EOC, the readiness standards are tested more heavily. So there are some supporting standards that won't be tested at all, and we can be assured that our readiness standards are going to be tested multiple times. So it's something to keep in mind, and that's the reason for the distinction in the unit plan. I'll go ahead and move on to the vocabulary. Here, coefficient versus constant versus variable is very important. It can go a long way in helping your scholars categorize rules and patterns later on in the year. So make sure that you teach this explicitly and you have them use that vocabulary. Expressions versus equations versus inequalities will help you get your point across when it comes to polynomials and factoring, and also graphing these when you hit linear functions. So make sure that you're having them use that terminology consistently and that you're also doing the same. Like I mentioned before, this is essentially a pre-algebra unit, so this is setting the foundation for units to come. The last part of the stage 1 portion of the unit plan is interdisciplinary connections. There are always connections with sciences. In this case, literal equations really help us out a lot. This is a great time to introduce some high-level equations, even if scholars don't have the background to understand what each variable represents. I also made a connection here to physical education. I talked about playing defense in sports, zone versus man. It's just an interesting way to view functions in the real world, and I have a quick example of it here. So first of all, I'll talk about the AP Physics. Here, this is just an easy way to get some literal equations. You don't have to know what they mean, neither do your scholars, but if you can isolate a variable, then you're exposing them to something that they'll see in high school, something that maybe a few years down the road they'll understand a little bit better. Here we have a GIF, and in the GIF you can tell here that at some point 2 defenders are attached to one offensive player, which is not a function. It's not okay. Those 2 x's can't have the same y, and that results in bad defense. Now, it's a loose connection, I'll give you that, but it's something that maybe will pique some of your scholars' interest and will help you out. Stage 2 will not usually be this empty. The unit assessment is a multiple choice and constructive response assessment. In later units, when we cover the different criteria, there'll be different forms of assessment, but with this unit, it worked best to have a traditional exam. Matches up with the skills that we're assessing the scholars on. I did include some suggestions as to how to still make a meaningful connection to the broader topics in stage 1. You could have some real-world inequality problems. Not generic, this person needs less than that person, but something that truly exists out there. Let's say 2 people, 2 different starting savings accounts. One's college educated with a matching salary, and the other a high school dropout with a lower salary. Will the dropout ever have a savings account greater than the other? Or how long will it take a college educated citizen with a huge student loan debt to save for their first home compared to someone who doesn't have debt but maybe started with a lower initial salary? You can incorporate some real world concepts here, even if they are a little bit simplified. That's okay. They're not going to call you out on that stuff. Beyond that, there's also the possibility of having some great reflections. What inequality exists in your scholars' lives that maybe prevented a good score on this test? Or maybe the flip side. what even put them at an advantage in comparison to other scholars. Lots of ideas to try out here, and something that I would love to hear back from you guys about. But that's really it for stage 2, since there is not a huge performance task or rubric to go over. So now I'll move on to stage 3. So this is kind of chunks of stage 3, but some things that I think are really important. Stage 3 is really the nuts and bolts of the unit plan. How are we teaching? What are we teaching? For those of you who might feel a little bit lost right now or overwhelmed, this is a really great starting point just to be able to understand what's expected of you in terms of curriculum delivery. For each day, there's a learning experience, a teaching strategy, and differentiation suggestions. They're in the top part of stage 3. These are suggestions, strategies that have worked for me in the past, or experiences that I feel like bring back a lot of value. Annotated model lessons are noted here. Both are 5-step lessons, which I think makes sense. I'm going to come back to these examples after walking through the objective calendar, which is what I'm going to move on to right now. Okay, so this is the objective calendar, the last part of stage 3. You have the day 1 obviously to start off with, the date where you are supposed to be delivering this lesson, the learning objective, the key points to help guide your lesson, and then at the end the assessment summary or the exit ticket. To start off with, you're going to be determining if a given relation represents a function. Pretty straightforward. Most people use the soda machine function rule, which I think is really great. A lot of people use people and places, so more than one person can be in a given place, but one person cannot be in 2 places at once. However you choose to use it, this is essentially defining what a function is. If you choose to veer off from this assessment summary, please make sure that you're assessing multiple representations. Do not just give a bunch of ordered pairs, because that's not the level of rigor that's matching our EOC and our CAs. So that's essentially day 1. Day 2. This is determining the domain and range of discrete relations. Now, you see a W here. This is supposed to be given on a Wednesday. I know some of you guys have shorter days or shorter lessons on Wednesdays, and that was kind of done on purpose. Discrete domain and range should be something that's pretty simple. A heavy emphasis on actually defining domain and range. Your scholars have probably never heard of this before, so make sure you're defining it well and asking consistently for them to define it themselves, because actually writing the domain and range from all of these multiple representations should be fairly simple. Day 3, this is that AML. We're talking about representing domain and range of continuous relations. This is big. This is not just an Algebra 1 concept. This comes back in Algebra 2, in Pre-Cal, and on and on. Your scholars probably do not have a lot of familiarity with these relation signs, so it's important to define those and to explain those. Your scholars will have a tough time with this lesson for the most part, and that's part of the reason why it was chosen as an AML, and I'll come back and talk more specifically about how I teach this, and maybe that would be useful for you guys. Day 4, this is determining reasonable domain and range for real world situations. Now, I mentioned this before, talking about how you should try to push that analytical piece on your scholars so that they can really start to think about whether their solutions make sense or not given the context of a real world problem. This is something that I know my scholars struggle with. This is something that, in all honesty, I'm okay with poor exit ticket scores if I think that we're making progress, because I know that I'm going to spiral this in continuously. Look back at CA data from previous years, and it's questions like these that trip up our scholars. So don't think this is a one and done. Get it out there, explain it to them, and then make sure to spiral continuously and to go after those misconceptions. Day 5, rewriting equations into function notation and then evaluating those. This can be a very, very simple day, or it could be a kind of confusing day. Some scholars, this just clicks. All we're doing is replacing y with f of x or a function of x. And I think sometimes that kind of gets in my way as a teacher. I think this is so simple, we're going to rush it and we're going to have a ton of practice. And what ends up happening is scholars see that f of x as multiplication or some sort of tiny distributive property. Really, it's a label. If you take the time to make sure you're describing this correctly, it should work pretty well. Day 6, another AML, multi-step equations. I'll talk more about this in a second, but really this is something that if you feel like your scholars cannot master this in one day, you need to find a way to minimize the amount of time that you're spending introducing this. We'll go over it again in inequalities. You'll have a flex day afterwards. Don't spend 5 days gearing up for this lesson and end up semester 1 kind of running out of time. Day 7 is a Wednesday, multi-step inequalities. This is a continuation of what we were doing previously. The only addition is that inequality rule. So this should be a day to really practice and really get those multi-step inequalities, multi-step equations correct. Day 8, similar story, literal equations. This is a great time to do a side-by-side model for your INM. Solve a literal equation while at the same time they're solving a numeric equation or a one variable equation that looks exactly the same and has the same steps. Show them that they've done this before. The only difference is that there are variables instead of numbers. Day 9 and day 10, unit review, focusing on those skills that they didn't really do so well on. And then of course day 10, that unit assessment. This is up on Blackboard. If you have any questions about this stuff, please reach out. Like I said, this was pretty quick, but there shouldn't be too many questions. This is a pretty straightforward unit. Now I'm going to go back to the beginning of stage 3 and share some of those specifics that I was talking about previously. Okay, so a few stage 3 things I wanted to highlight. Day 3, the continuous domain and range AML or annotated model lesson. I like using note cards to get scholars to get the two endpoints of the compound inequality. So I tell them to imagine a set of note cards squeezing the relation in from both the left and the right. The note card stops as soon as it hits the relation. Then they ask themselves, is this really as far left as that relation goes? If it is, then they write that number down. If it continues forever, then they write an infinity. There's still subtle things that they need to check for afterwards, like the or equals to. Was it a solid dot or an open dot? But it helps to have this to start with and then build off of it. So that's a note card coming in. It stops as soon as it hits the relation. You ask yourself, is it really stopping there? It is. You have that -4 value. Same thing on the other side. It stops. 2 isn't really the value because the relation doesn't really stop there. So we write an infinity down. It's a simple process and something that can be repeated for range as well, with just the note cards coming in from the bottom and coming in from the top. This is explained a little bit more in the AML, and I'll have a little bit better resources for you guys once that gets posted. The other day I wanted to highlight was the other AML, which is day 6. Day 6 is multi-step equations. I'll start off by saying that most of my 8th grade algebra scholars are not ready to jump into multi-step equations cold. If you look at these example problems here as your lesson assessment, my scholars just aren't going to be able to do that without some sort of scaffolding up. They just don't have the background knowledge. Unfortunately, we don't really have spare days to spend on simplifying expressions and describing like terms and everything else that goes into this one skill. This is a dilemma you could face frequently, and this is where I try to use my do nows, my fluency drills, and prior homework as sort of a mixture of pre-test and scaffold. I mentioned in the teaching strategy that you should use the do now to identify misconceptions or gaps in their background knowledge, and then use that to inform your INM. You're going to be doing an explicit instruction here, so you need to make sure that if they don't understand one of the steps, that you're taking your time there and asking a lot of CFUs. You should also use catch and release. This model will slowly progress them up to the level of rigor that they should be at. Beyond that, I would use some worked out examples so that scholars could self-check. This is kind of the strategy that I put in the differentiation. This tends to be a day where I wish I had more people in my classroom helping. Lots of hands up, lots of questions. This small bit of pre-work can help lessen the load on a tough day. So that really is Unit 1 in a nutshell. A few last reflections to finish off this unit preview. As important as all of these skills are in this unit, the emphasis on correct vocabulary could be a game changer for you and for your scholars. If you've ever found yourself changing your correct math vocabulary into simpler incorrect terminology for the benefit of your students, this is really the year to change that practice. And this is the unit to begin that change. It will be an immense help to your students even if they can't tell. Apart from that, make sure to use the resource bank, curricular documents, and textbook to ensure that you're aligned to the EOC and of course your CAs. We're still fairly new into these TEKs, and some problems or resources that may look amazing can lead you and your scholars away from those essential knowledge and skills that you need to be assessing. I know that's happened to me, and I don't really want that for any of you guys. Alright, so that's about it for this unit. As always, please be sure to reach out with any questions, comments, or concerns. Thank you guys for all of your hard work. I hope that I can make this your best year yet.